Alright, so we're given this integral and you're supposed to find the solution, right? Okay, so again, generally speaking, when I look at these questions, I try to go through a checklist of ways to try and solve them. Okay, so generally, first I'll let's do green first. So there are a couple of methods that you know that we can use. We can we can use integration by substitution. So that's basically using u substitution, right? And then there's also then integration by trig substitution, and then there's integration by parts, right? Okay, so it should be noted that sometimes you might have to use multiple of these to solve a problem, right? So generally speaking, I find that integration by substitution, if possible, is the most straightforward thing we can do, but sometimes it's just not feasible, so we have to try other ways to do it, right? So for example, in this case, if you wanted to do integration by substitution, right? So what would be substitute for u in this case? So what 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 would u equal to? Well, if you let u equals 2x, okay, that's fine. So if you let u equals 2x, if we okay, so let's try that. So let u equals 2x, okay, then du equals 2 dx, right? It's just this du dx, and then I just take the derivative. Okay, but there's an x out here. Okay, so how would we what would we replace that with? Well, maybe we can try x equals u over 2. Okay, but does that really help us though? Right, so if we just plug this in, what do we get? We get the integral of u over 2 e to the u. So du is, so just from here, du over 2 is dx, right? So we substitute du over 2 into dx, we get du 2, right? And that gives us, so you can pull this one, so this is 1/4, you can pull this 1/4 out. This gives us ue to the u du. Okay, okay, so now what? Well, what if, well, now it's sort of stuck, right? Can we differentiate this in any way? Can we do substitution? No. Can we do by trig? No, doesn't look like it. What about, okay, so by parts, right? So by parts looks like maybe we can do that. So let's, well, so substitution didn't help, right? So let's just this didn't work. So I'm just going to say nope, that didn't work. Okay, so the integration by parts, sorry, the integration by substitution wasn't working out. So let's try out. So this is subs by substitution. Okay, let's try by parts. Okay, right. So let's just recall what the integration by parts formula looks like, right? So it's just, so it says that if we have some integration that we have to perform that's in this form, then that integral is given by f of x g of x minus the integral of f prime of x g of x. Okay, so if we have an integral of this form, we can do it this way. Okay, so what we need to do now is sort of decompose this thing down, right? So what is going to be f of x, and what is going to be g of x, g prime of x, from this, right? And this is a bit of trial and error involved, but the idea is, so if you want, so remember that we need to find f prime of x eventually, right? Because we need that here, and we also need a g of x eventually, because we need that over here and over here. Okay, so we should ideally find some way, some means of decomposing this down in such a way that it's not too difficult or complicated to get the derivative, and it's not too crazy to get the integral, right? So it should be doable in some sense. Okay, and this is just a matter of practice, and you get a hang of it as you do more and more of these problems. So for this problem, I'm gonna say we're gonna let g prime of x be e to the 2x, so this component, and then let g prime, oops, sorry, I meant g prime of x be e to the 2x, and let f of x equals x, right? So this is because x is really easy to integrate. Okay, and also it'll make this much easier, because if we just have a 1 here, then it's just this part that we have to integrate, right? So the derivative of f of x is just 1, okay, because it's just x, and the integral of so now we need the integral of e to the 2x, right? So just do a different color. Okay, so we need this. So this is the integral, oops, we need this. So this is the integral of e to the 2x dx. Okay, so now this is a good candidate for substitution, right? So because if we let u equals 2x, then du equals 2 dx, right? We just so this is du by dx, we multiply both sides by dx, we get this side. Okay, and du over 2 equals dx, and we have all the components we need to substitute this in, so we can say this is the integral of e to the u du over 2, which is the integral of e to the u is just e to the u, so and we have this minus half outside, so that's just e to the u over 2 plus c. Then you plug this 2x back in to get e to the 2x. You remember u is 2x, right? And then divide that, sorry, divide by 2 plus c. Okay, so we have this is just e to the 2x over e to the 2x over 2 plus c. Okay, all right, so now we are on our way, so we can just bring all the parts together, right? Just gonna, hence the name, integration by parts, right? So just gonna bring this, so I'm gonna bring all of this together, right? Bring all of these things together. Okay, so we have the integral of x e to the 2x dx is f of x, which is x, times g of x, which is times e to the 2x over 2, right, minus the integral of f prime of x, which is just 1, times g of x, which is e to the 2x over 2. Okay, you know the plus c here, but just leave it at that. And so now we just have to integrate this thing, right? So it's just x e to the 2x over 2 minus 1/2 times the integral of e to the 2x, right? And we already did this over here, the integral of e to the 2x dx, which is just this thing. So that's just gonna be x e to the 2x over 2 minus 1/2 times e to the 2x over 2 plus c, which is x e to the 2x over 2 minus 1/4, well, minus e to the 2x over 4 plus c. And that is our answer.